All right, well, let's do what we always do in here. Let's greet each other properly. Good morning.
Good morning.
All right, this is Mr. Ainsworth. We're going to get into Section 8.4 on trigonometry here, and we're going to be talking about what's called the sine and cosine ratios. So the first thing we ought to do is we ought to go ahead and label the triangle. Thank you. So let's label first. Label first. You're going to see me do this in all our lessons here, in all our examples. And I'm going to define the sine, the cosine, and the tangent ratios, abbreviated SIN, COS, and TAN, first three letters of each word, by using angle A. Remember, this is an angle now, okay? So your focus has to be right on here in A. So the very first thing we do is we label the right triangle. Let's put the right angle in there, according to angle A. All right, and side opposite of C, or angle C, the right angle, is the hypotenuse, the longest side. Is always opposite of the right angle. That's pretty evident. The one that's furthest away from the angle, okay, is called the opposite side. So BC is the opposite side of angle A, opposite of angle A. And even though the angle A has two adjacent sides, the longest one's called a hypotenuse. Okay, the adjacent side's always a leg, and so this is the adjacent side here, abbreviated ADJ. OPP for opposite and ADJ for adjacent, where adjacent means next to. And once you have all those labels in place, what you can do is form the definitions for sine and cosine, which is new for you guys. They're different ratios than the tangent function. Okay, so let's define them on the right-hand side here, and then after we define them, we'll put it all together, and I'll show you how to use them and in different situations. Okay, first of all, the sine of the angle. Now notice that I'm using capital letters too, by the way. In customary mathematics in all classes, geometry on up through calculus, to use uppercase for the angles and lowercase for the sides. Let's repeat that. Uppercase for what? Angles, and the lowercase for? Sides. So if you see a capital A, you need to be thinking, hey, that's an angle, okay? So the sine of the angle is defined to be the ratio of the opposite side, OPP again means opposite, so opposite side of angle A divided by the hypotenuse, and that's new. The tangent function did not involve the hypotenuse, where the sine function does. So this is a new ratio for us today. The sine of the angle, again, this is an angle up here, is equal to the opposite side of angle A divided by the hypotenuse. It's a different ratio. The cosine ratio, cosine of angle A, is different as well. All right, we define the cosine of the angle as the adjacent side, ADJ for short, okay, of the angle. So adjacent side divided by the hypotenuse. Okay, and then like in our last lesson here, when I defined tangent, we defined the tangent of an angle as the ratio of the opposite side of angle A, divided by what? Help me out a little bit. Opposite divided by? Adjacent. Very good. So adjacent side of the angle. So the very first thing what we need to do before we start using these definitions and the ratios is come up with a simple way of memorizing and putting these definitions together to help us solve all the problems. Okay, so what we're going to do is we're going to form an acronym of our definition, so it helps us memorize this because there's a lot going on right here. And so what I'm going to do is I'm going to take the first letter of each major word, S for sine, O for opposite, H for hypotenuse, and then C for cosine, A for adjacent, H for hypotenuse, and then T, and then O and A. And I'm going to form a word out of this called an acronym, much like our school acronym, GOHS. It stands for Great Oak High School. We're going to form a word out of this. Will help us memorize all three definitions and help us apply it later on when we do some actual problem solving. So what I'm talking about is S-O-H-C-A-H-T-O-A. I'm going to form a word out of this. All right? And again, it's called an acronym, and it's to help us remember all of these three definitions here. So S-O-H comes from sine. Stands for sine is opposite divided by hypotenuse. C-A-H right there stands for cosine is adjacent divided by hypotenuse. And then T-O-A, TOA, stands for tangent is opposite divided by adjacent. So katoa. Okay, everybody say SOHCAHTOA. Okay, and we're going to write this crazy word down next to every single problem to help us use it and memorize our definitions. But before we do, we're going to write it in a slightly different way, because what you have to remember is how to write the ratio. And you have to know what's in the numerator and what's in the denominator. That's important. So I'm going to rewrite it a little bit different way. I'm going to switch to red, and I'm going to highlight this. Okay, we're going to write SOHCAHTOA like this, S-O-H. Because what you need to remember here is that sine is opposite divided by hypotenuse, and it kind of looks like a fraction right there. Okay, because it is. It's a ratio of two sides, opposite divided by hypotenuse. And then cosine, let's write it like this, C-A-H, where you know that the adjacent side is being divided by the hypotenuse. And then TOA will be written like this, because it's opposite divided by adjacent. Okay, and we're going to commit this to memory. So we're going to memorize this, and it's going to be easy because when we do our homework in the book tonight, when you practice your lesson problem here, is that we're going to write this crazy word down called SOHCAHTOA down next to every single problem. And by the end of your lesson, your homework, you're going to not only have it memorized, but it's going to be a lot more easy to use. Okay? So let's get some practice here, like we did in last lesson. And the very first thing we did in last lesson on the tangent function is we took a 30, 60, 90, and we labeled the sides, and we just wrote a few ratios, just getting used to this. So we're going to do the same thing. We're going to take a 30, 60, 90. Here's a 30-degree angle. Here's a 60-degree angle here. I'm going to label one of the sides. And then afterwards, we're going to be able to find the sine of angle A, the cosine of A, and the tangent of B. But first, we've got to label the sides. So let's suppose that I put a 6 here in the hypotenuse. Okay, let's suppose that's 6. The very first thing you need to do before you write the ratios of sine of A, cosine of A, and tangent of B is that you have to label the other two sides. And since we already studied this, we can do it. So how do you get from hypotenuse to short side? Divided by 2. So 6 divided by 2 equals 3. So the short side's 3. And to get from the short side to the medium side, we got to multiply by something, because we're getting longer. We're going to multiply by what? So what's side CA? 3 root 3. All right, we multiply by root 3. So once you know your sides, given one of them, because this is a special right, then you can answer these questions right here. What in the world is the sine of angle A? And this question is asking you, what's the ratio? What's that ratio? The sine of angle A is a ratio of opposite divided by hypotenuse, okay, as stated up there at the very top. So here we go. Let's get your attention right here. Your attention here, or your focus is on angle A. You'll see a little highlight, or my little cursor there right around angle A. And the first thing we need to do is figure out what's opposite of that. So you go directly across. What's opposite of 30 or angle A? 3. So that's opposite. Now hypotenuse is 6. Let me see. So we define sine as opposite divided by hypotenuse. So it's got to be 3 divided by 6, or 1/2. It's a ratio. The sine of an angle is a ratio. You take the opposite of that angle divided by hypotenuse. Okay, in the previous lesson I did it for tangent, and I took the opposite divided by adjacent. Today the sine function is different. It's opposite divided by hypotenuse. Now let's do that a few times. Let's take the cosine of angle A now. That's a different ratio. If you look up top, CAH, the cosine is defined to be the adjacent side divided by hypotenuse. Okay, so get your attention. You're right here. Here's angle A. What's adjacent to it? Say it loudly. 3 root 3. What's hypotenuse?
6.
So it's 3 root 3 divided by 6. So we take 3 root 3 divided by 6. We simplify this a little bit. 3 6 is 1/2. And what you get is root 3 divided by 2. Okay, so this type of question here is not a calculator problem. It's simply asking you to write some ratios, because the cosine and the sine and the tangent is nothing more than a ratio of two sides. That's all it is. And then the last thing we need to do is find the tangent of angle B. Okay, now your eyes have to change positions to angle B. Now get your eyes right here. You're at angle B. The tangent is defined to be opposite divided by adjacent. Eyes up here. What's opposite of angle B? What side? 3 root 3. What's adjacent to angle B? 3. So we got to take 3 root 3 and divide it by 3. So we take 3 root 3, divide it by root 3 and simplify, and we get 1 root 3 or root 3. Your first few problems on your homework are identical to this. So use your notes side by side with your homework. And it was the same in the last lesson too. I just wrote some tangent ratios in the last lesson. Your homework, the first few problems were like that. The first few problems in your practice worksheet were just like that. Okay? And then I switched to the 45, 45, 90, and I did the same thing. Okay, so let's put the angles in. By the way, what type of right triangle is the 45, 45, 90? Starts with a capital I, say it? Isosceles. Okay, let's write that down. So it's isosceles. You have to recognize that it's an isosceles triangle, the 45, 45, 90. So notice that I marked the two legs congruent. It comes from a square. That's the reason why that's the case. And we want to find the sine, the cosine, and tangent of angle B. We'll do that in a minute after we put down some sides. So let's suppose that I give you the length of hypotenuse, let's say. And I'm just going to make up a number like 12. Let's say that's given. Okay, and this is the hypotenuse. Okay, what you have to remember from lesson 2 on the special rights is you have to remember how to get from hypotenuse to leg. So since we're getting shorter, are we going to multiply or are we going to divide? Divide by what? Root 2. Okay, so here we go. Divide by root 2. And let's do the arithmetic off to the side. Let's take 12 divided by root 2. I talked about in that lesson that we have to rationalize the denominator by multiplying by a fancy form of 1 like this. Because you're not allowed to leave roots in the denominator, so we say that we rationalize the denominator. We get 12 root 2 up top. Root 2 times root 2 is root 4, which is equal to 2. Look up here. We got to simplify a little bit. 12 divided by 2 is 6, and we get 6 root 2. And so now we know both legs are 6 root 2. So if they don't give you the sides, well, you got to find them. Okay? If they're special right triangles, then use these techniques. If they give you 2 sides and not the third side, and it's not a special right triangle, use the Pythagorean theorem. Okay? You got to adjust depending on what they give you. Okay, and now we can do this. Okay? So let's find the sine of angle B now. Now remember, it's a ratio. So I'm going to write down so, ka, toa again. Why? Because we need to have it in our sights. We've got to be able to see it, because this is the first time you guys have ever seen this stuff probably. So look at right here. So SOH, the sine function is opposite side divided by hypotenuse. So if you're at, let me see, work with angle B. So at angle B, 6 root 2 is the opposite side. Okay? The hypotenuse is 12. So the sine of angle B has got to be 6 root 2 divided by 12. It's opposite divided by hypotenuse. Okay, and then you got to simplify a little bit. The 6/12 is 1/2 actually, and we get root 2 divided by 2. And let's pause here for a moment and see if you have any questions. Let's move on. Let's move on to an actual problem. Oh, wait a minute, I'm sorry. I didn't finish, did I? Get a little distracted here. So we found the sine of B, now we find the cosine of B. So I'm not done with this example yet. So the cosine of angle B. Now cosine is CAH, okay? Cosine, adjacent divided by hypotenuse. So the adjacent side of angle B is 6 root 2. See my little cursor floating around here? It's adjacent to angle B. And the hypotenuse is still 12. So the cosine is still 6 root 2 divided by 12, all right, which gives you the same thing as the sine of angle B. It gives you root 2 over 2 when you simplify. It just so happens on this triangle that the sine of B and the cosine of B are the same because it's isosceles. That's the only reason why. Okay, and the last thing we need to do is the tangent of angle B. This one's different. Okay, the tangent is opposite divided by adjacent. Question? Okay. So again, we're at angle B. We're right here. Opposite side is 6 root 2. The adjacent side is 6 root 2. What's 6 root 2 divided by 6 root 2? It's 1. Okay, so the tangent of angle B happens to be 1. But let's put down how we got it. We got 6 root 2 divided by 6 root 2, which is 1. Now let's make a connection from last lesson here. Angle B in this problem is what measure? I didn't label it. What should it be? Yeah, it's a 45, 45, 90, okay? Angle B is 45 degrees. Use your calculators right now. Take the tangent of 45 degrees. And give me a thumbs up out there if you get one. You got 1, 2, 3, 4. Yeah, the whole class is, yeah. There you go. And we did that the other day. On lesson 3 on tangent, we took the tangent of 45 degrees and we found out it was 1. So our calculator is verifying what we're getting on paper. All right, who's good up to this point? Any questions up to this point before we try some actual problems? Okay, let's turn the page and let's try our first example here. Okay, in this problem here, we got two unknown sides. We know what angle B is, it's 57 degrees, and we know what side BC is, it's 43. So what we're going to do is we're going to find x first. Not that you have to find it first, it's just that I choose to find it first, and then afterwards we'll find y. Okay, but first we label. So we always label first. Label the triangle. Okay, now your focus should be right here at B because you know the angle. Okay, I'm not going to use angle A, although we could. We could find angle A and use it, but I'm going to just do it the easy way. I'm going to start off with the angle we know, which is 57 degrees, and we're going to label these sides. So let's do that together. What's side AB or Y? What's that side? What's Y? Hypotenuse. Okay, good. And what does 43 represent in respect to angle B? Don't say short. Say either adjacent or opposite. Adjacent. Okay, yeah, it is the short side, but it's the adjacent side. And then the furthest side away is called the opposite side. Opposite of angle B. Okay, opposite sides. And once you have those identified, then you can actually go for it. And then the deal is, what function do you use? That is the first thing that a student has to figure out is what function out of the three to use. So up here, write down SOHCAHTOA. SOHCAHTOA. Again, I want you to write that down in every single problem so that you have it memorized by tomorrow. SOHCAHTOA. Okay? So the question is, which function should we use? So this is how you answer that question. Bring your eyes up here. We're trying to find x and not y. So you can only find one variable at a time. So I'm going to cover up y. And notice we only have these two sides we're dealing with. We're dealing with the opposite side and the adjacent side. And what function deals with those two sides and not the hypotenuse? Which function? Tangent. Yeah, because sine deals with the hypotenuse. Cosine involves the hypotenuse. And if you don't even know what it is, nor are you trying to deal with it, then you can't use the functions that deal with the hypotenuse. So you can't use sine, you can't use cosine, you have to use the tangent function. That's the very first thing you need to realize in this problem, is that to find x, you have to use the tangent function. You can't use the other two. Okay, so let's try the tangent. Let's set up an equation here. Here we go. So the tangent of our angle, 57 degrees, is equal to the opposite side divided by the adjacent side. So opposite is x divided by the adjacent side, 43. There's your setup right there. Now I want to see the setup on every single homework problem. I want to see it set up on your practice worksheets, and I want to see it on quizzes and tests. I want to see your setup. And I want to see that you step it out. So since the denominator is 43, to solve for my unknown here, I need to multiply by 43 on both sides to clear my fractions. 43 divided by 43 isolates x there. So x is 43 times the tangent of 57 degrees, whatever that is. And that is a calculator problem. So let's get our calculator going here. And let's turn this on. And let's take 43 and multiply it by the tangent of 57 degrees, and let's round it to the nearest thousandths. So you look at the fourth digit, which is a 1, and you round the third digit, which is a 4. So we get 66.214 if we round it to the nearest thousandths. So let's write that down. 214 is approximately equal to x. Now if you're not getting these values out there, let me know immediately, and I'll pause the video and I'll discuss how to do it on. Some of your calculators are old, and you don't type them in directly like I did. All the new calculators, you type it in directly as I did. But the old calculators, you got to enter in the angle first, then hit the function. So if you're not getting that value, let me know right right at this moment. Okay, so now we found x. Now we got to find y. So what we do is we cover up x and we look at what we're dealing with. So i's back up here. Even though we know x, we're not going to use it because we want to use the exact value of 43 as opposed to the approximate value of 66.214. So let's not use x. So let's use the adjacent side and the hypotenuse. So which functions out of these three deal with only adjacent and hypotenuse sides? The cosine. It's adjacent divided by the hypotenuse. And that's how you identify which function you guys are going to be using. So this time we're going to be using the cosine. So here we go. So we're going to use the cosine function. So the cosine now of our angle 57 degrees is going to be equal to the adjacent side 43 divided by the hypotenuse y. Okay, that's your setup. Now you got to step it out. Now y is in the denominator and you don't want it there. Alright, so to clear your fractions, you're going to multiply both sides by y. We did this in the previous lesson too when it involved tangent. Whenever the variable's in the denominator, multiply both sides by the denominator, clear your fractions, and step it out. And you get y times cosine of 57 degrees is equal to 43 now. Now whenever the variable's in the denominator, it's a two-step procedure and not a one. At this point, y is not isolated. We got to divide both sides by the cosine of 57 degrees. Okay? And you get y is approximately equal to something. And at this point, after you did the two-step procedure and you stepped it out, then you go to your calculator and you figure out what this baby equals. And it's the hypotenuse, so it better be bigger than 66. If x is 66.214, the hypotenuse has got to be longer than that. So I'm expecting an answer bigger than 66. Let's see if we get it. So we've got 43 divided by cosine of 57 degrees. And lo and behold, I do get an answer bigger than 66, which I predicted. I get about 78.951. So 78.951 units. Okay, let's pause here and ask any questions. Okay, so moving on, let's go to example 2. Here we want to find the height of the clouds. So let's call that h, and let's label the diagram. That's h, the height of the clouds. And that distance right there is perpendicular to the ground, so we have a right angle in there and we have a right triangle. And the angle between the hypotenuse and the ground is 35 degrees. I'm going to enlarge it a little bit. This distance right here is 525 meters. The question is, how high are the clouds? So once again, the very first thing we do is we label sides. Label sides first. In respect to angle 35 degrees, so your attention is right here. There's your focus. This is like you're right here on the vertex. All right, what does that 525 represent? The opposite or adjacent side? Okay. And what does h represent in respect to the angle? Everybody? Opposite. Okay, now write down SOHCAHTOA again. SOHCAHTOA. Get in the habit of writing down every single time, and let's circle the function that we want to use. Tell the person next to you what function up there. When I say function, I'm talking about sine, cosine, or tangent. Which one deals with opposite and adjacent only? Okay, you heard it go around the room. Everybody said the tangent function. Circle that one. So let's use it. Okay, we need to set up a tangent function, so we're going to say the tangent of our angle, which in this case is 35 degrees, is equal to the opposite side, h, divided by the adjacent side, 525. Okay, now then there was a question earlier, just a minute ago. I said, hey, how do you know what number to multiply both sides by? And my response was what? Always look at where? Denominator, and the denominator is 525. So I'm going to multiply both sides by 525 to clear my fractions. 525 divided by 525 is 1, and that allows me to solve for my unknown, which is the height of the clouds, h. So what I need to do on my calculator is I need to enter in 525 and to multiply it by the tangent of 35 degrees and see what we get. So 525 times the tangent of 35 degrees, and we round it to the nearest thousand, so we look at the fourth digit to the right of the decimal. That's a 9, so we round the 8 up 1, and we get about 367.609. So 367.609 meters is the height of the clouds. Okay. Any questions on that one? Give me a thumbs up if it's making sense. No? It's getting a little easier than the first lesson on trig. On tangent. The first time you saw a tangent, that was the first trig function you ever saw, and things were getting a little weird, weren't they? Going, what in the world is this guy talking about? But hopefully it's getting easier by now. Yes?
Are we always going to have to round?
Question is, are you always going to have to round? And anytime you use a trig function, yes. Because it's an infinite decimal. So typically in my class, I round it to the nearest thousands and look at the fourth digit, round the third. However, you just read the instructions in the homework, and if it says round to the nearest tenth, you go with the flow, or nearest hundredth. But yeah, whenever you're using trig, you're going to have to round. Because very seldom do you get a whole number.
Because my calculator rounded for me.
Well, okay. Then you need to set it to 10 digits, and so you can do your own rounding. Okay, let's try the last one together here. Number 3. Once again, you always label first, as I keep saying. Now we want to find angle A. And then after that, we have to find x. So it's a two-step procedure here. Now, whenever you find an angle, as I was talking about in last lesson on tangent, whenever you find an angle, it always involves the inverse. Okay, so let's highlight this on the left-hand side. So whenever you find the angle or find an angle, okay, whenever you find an angle, it always involves an inverse, either inverse sine, inverse tangent, or inverse cosine. So it always involves, okay, an inverse. Okay, so keep that in mind. That only happens when you find the angle. If you find the side length, it never involves an inverse, but whenever you find an angle, it does. Okay, so here we go. We label the sides first. So since we're finding angle A, your attention is here. Your focus is right there. X refers to what side in respect to angle A? Very good. It's the adjacent side. 17, since it's opposite of the right angle, is the hypotenuse. HYP for short. And then the side farthest away is the opposite side of that angle. So after you identify the sides, you're good to go. We have to pick a function here for angle A. So here we go. This is it. Which function do you use? So what you do is you cover up x because you don't know what it is. The only two sides you know are opposite and hypotenuse because they're 8 and 17. Look up here now. Which function, well, I didn't have SOHCAHTOA written down, but which sine, cosine, or tangent deals with opposite and hypotenuse?
Sine.
Okay. In fact, let's write down SOHCAHTOA again. Okay, so SOHCAHTOA. Okay, and we're going to use the sine here. Why? Because we know what the opposite side is, we know what the hypotenuse is, so it makes sense to use it. So let's take the sine of angle A. Remember, capital letters refer to the angles. It's going to be equal to the opposite side 8 divided by the hypotenuse 17. Now one of the things I want you guys to do is learn how to say it and learn how to write it and learn how to step it out. On your homework, I'm looking for the steps, and if I don't see them, I'm not signing your work. And on your quiz and in your test, I will need to see the steps. Otherwise, I'm not going to give you credit for that. I need to see that you know how to write it and do it. So here we go. We're going to take the inverse sine of both sides. And it looks like this notation right here. You're going to take the inverse sine of the left side, which is the sine of A. And then you're going to take the inverse sine of the right side, which is 8/17. And that's the only way to correctly write this. There's no other way to correctly write taking the inverse here, or the inverse sign. So make sure when you write it down in your notes, you write it exactly the way I did and practice that way. The inverse of sine is called sine inverse. The inverse of tangent is called tangent inverse, and so on, okay? Now this part right here, the inverse of sine of A, the inverse sine of sine of A, the inverse sine cancels out the sine, giving you the angle. That's why we use it. They basically cancel, the functions cancel each other out, which is something that happens with all inverses, okay? And then this right here, the right-hand side, is a calculator problem. So here we go. I'm going to take this inverse sign, go second, and then sine. You'll notice that the same notation comes up on the new calculators, not the old ones. Okay? And then you go 8 divided by 17, and then you hit enter, and you get about 28.072 degrees. 28.072 degrees because it's an angle. The older calculators, and some of you guys are using them, like you're using one there, a few of you guys are using them, what you have to do is this. You have to type in 8 divided by 17 and hit the equal button. 8 divided by 17 equals, and you should see a decimal there. It should be around point, what do you have, 0.6 something? 8, no, okay, yeah, it's a little less than half, so it's about 0.4 something. Okay, then go second sine, and then enter, and then you should see the same angle that I'm getting, about 28.072. So on the older calculators, you enter the ratio first. You go 8 divided by 17 equals, and then go second sine, and you get the same answer. Okay, and let's record that. Okay, and then we got to find the unknown x. And there are two ways to do it. You can use trig, or since you know two sides, you can use what famous theorem? Starts with a P. Pythagorean theorem. So let's write it down. Pythagorean theorem. And you could set it up. You can take 8 squared plus x squared and set it equal to 17 squared and use your theorem. And hopefully some of you guys out there are thinking, we learned 4 Pythagorean triples in lesson 1. And since I know my triples, I know what that answer is without even doing that. Anybody remember that triple? What was it? Yeah, well, okay, the triple was 8, 15, 17, right? So you knew x had to be 15. Be honest with me, did anybody remember other than Elizabeth? We got 3 or 4, oh, well, 5 or 6 people. That's pretty good. Okay, so x is 15 after you do your arithmetic. Let's record it. It's a triple. It's an 8, 15, 17 right triangle or triple there. It comes from, we discovered 4 triples in lesson 8.1. If you go back into your notes, you can check them out. And that was one of them. Good job. Okay, and that's it. And what you got to do is get used to it. So go ahead and turn the page. On the next page is a summary. This is our acronym that we want to memorize and write down and use on our homework. The next page is our 8-4 practice. Let's go to that right now and let's write down a few things. Okay, first of all, let's write down SOHCAHTOA on the very top, big and bold. SOHCAHTOA. Say it, SOHCAHTOA. Okay, put that on the front. The answers are online. Print, and one of the things I want you to do is print the answers online, and I want you to bring them to class tomorrow. Okay, and bring to class. The reason why is because you guys are going to be doing 8-4 practice in class tomorrow, and you need to have something to check all your work. So tonight, you go to my website and print off all the solutions, bring them to class, stick them in your notebook like you have, keep them there, and you can use that to check all your answers, all in Chapter 8. And then tonight, of course, you're going to be doing the book assignment, and then tomorrow in class, you'll be working on this. So this is in class tomorrow. The book assignment's at home tonight. And then, of course, I'll work with you when you get back.